So let's look at a composition function where we are going in a different order than maybe what you're used to seeing. So here I have the composition g of f of x, and I'm going to evaluate this composition at x for the following information. Start by writing it out of this form into g of f of x, and it might be a little bit easier to see, because what that's telling you really is that I'm evaluating the g function everywhere I evaluate that, I'm plugging in the f of x function. Okay, so what does that mean? Start by writing the outside function, which is 2 times x squared minus 9, right? That was my g of x function that's given here. Everywhere there is an x, I am going to replace it with f of x. So it's the 7x plus 1 that gets substituted inside of this set of parentheses, because I am evaluating the g of x function using f of x when I compose g of f of x. Okay, so now we're just going to do some algebra. First, the order of operations tell me I need to simplify this part that's raised to the exponent. So let's just leave the 2 on the outside, and we're going to FOIL or expand this. So I'm going to square the first, which would be 49x squared. I'm going to double the product. That is 7 times 1, which is 7, doubled, or times 2, which would be 14x. Square the first, double the product, square the last, and I still have this minus 9 here. The next part of this is to multiply, so I'm going to distribute the 2 into all 3 of those pieces right there. So 2 times 49x squared would be 98x squared. 2 times 14 would be 28x, and 2 times 1 would be plus 2 minus 9, because I removed the parentheses. The last thing I need to do here is 98x squared plus 28x minus 7 when I combine those like terms. And this right here, which is a quadratic, is the composition of g composed with f. Oops, that looks like GOF. G composed with f of x. And that's the solution right there.